Hello, my name is Alap Sagateros from Compete and Beyond. We develop softwares, write technical articles, and edit videos. And in this part, we'll be discussing about version control. It'll be divided into 6 parts. We'll start with the basics, then on branch, when we'll finish on the remote. Okay, on this part, we'll be discussing on the introduction. Okay, what are the problems that are being addressed by Git? And when we say problems, let's say we are working on a digital content and we're tired of copying projects into many folders in case we mess up or lose some files or folders. Or if you want to manage development path, when we say development paths, it could be trial, it could be a free version, or a test, or premium or freemium version of it. And if we want to develop, manage development of histories, and probably we want to go back in time and change some files or folders. If we are working with many people living in different locations, how do we communicate and share source code or files? And emailing you part of the project, or do we have other plans? Or if you are working with in open source projects, and last but not least, you want to tell your mom that I'm a contributor at Google, and your mom will be, oh, my son is at Google or contributor. Okay, version control. We can say it as a digital content time traveling mission, where it all starts with file or files in a project, and we have a small database, and this database keep records of change you have committed into a Git database. And this is very important. Any change record is checksummed using a SHA-1 algorithm, which outputs 40-digit hexadecimal file named binary file. And let's see how it works. We have the binary or blob file and the famous SHA-1 algorithm. Okay. When we say algorithm, it's a bunch of functions or a single function. And what we mean by function is we have the name, we can put a parameter as an input, and we have set of instructions, and it will output a result. And what this SHA-1 algorithm does is it receives file content, or basically file content, and it outputs a specific unique 40-digit hexadecimal value, and this hexadecimal value will be used as a key to refer to these binary files. And let's say within our project we have files, and what our Git does is it first takes snapshot. So what this snapshot means is it simply creates binary file, or just binary file, and this binary file will be referred by this 40-digit hexadecimal value. And this can be used as a key, and this is as a value. So it's basically value key pair. And within the .git folder of the Git directory, we can see a bunch of folders, and within those folders there are files, and these files, their file name is this 40-digit hexadecimal value, and within the files there are this binary content, which are the result of those original files. And what this snapshot does is it saves this within the git.git folder. And in case, for instance, if we lose one file, it allows us to recreate this original file from this binary content. And this binary content is referred to using this 40-digit hexadecimal value. And the last step will be, of course, is the commit. Within this commit, the commit action will refer to this specific key, and this is how Git database permanently saves or trace any change within our folder or within our project. So we can see it as a camera film where the original objects are the files, and the pixeled or whatever format the file are being saved as a binary file, and the file names as the 40-digit hexadecimal values. And we can recreate the original objects using by referring to the file names that have been recorded as the pixeled values, which is the binary format. So it's like recreating what is on a picture. So we have three states, and the three states are the committed, the modified, and the staged. And we start with the staged, and when we say staged, it means the snapshot where the files, or we can just refer to just one file, and this file has its own binary format, and it's referred by the 40-digit hexadecimal value. And at this specific moment, the file is being snapshot, and a blob object, which is this, is being created using the SHA-1 algorithm referred by this specific 40-digit hexadecimal value. And when we say commit, the file snapshot is recorded into Git database. It means this specific key is referred by the commit action. And when we say modified, the current file is different from the recorded file's snapshot. If this the original file has been changed, let's say delta or changed, it's different from the snapshot, and the Git will understand or will flag as it is modified, either if it's changed, either if it's deleted or something. So these are the three specific states that we need to understand. The first is committed. In fact, we start with the staged. Staged means the file has its binary format referred by its 40-digit hexadecimal value, which is key value pair. And the committed is when the file snapshot is recorded permanently into Git database. And the last is modified. After we take a snapshot, or after we committed the file, if we change the original file, Git will flag it as modified. Okay, and we have the three sections. We have Git directory, we have the working directory, and the staging area. Of course, they refer to the states of Git. Git directory is the file snapshots, objects, and other metadata that are being stored. It's basically what's everything within the .git folder of our Git project. And working directory, this is where we work on, and contains a single checkout pull from Git directory. And we haven't mentioned one specific thing, which is checkout. Back to our amazing drawing skill. When we say we can recreate the files that was deleted, I mean the original file was deleted, but we can recreate what was within the snapshot, we use the checkout command. When we say checkout, of course it will refer to to the files that were had the binary format, and this binary format will be recreated into the original file. And yeah, it's simply what it does is just recreate the original file from the binary file, which is of course referred by 40-digit hexadecimal value. And the staging area is a file within the Git directory that contains information of the latest snapshot, and it holds everything. Yeah, and this staging area is where a file within Git directory, it's a file within Git directory that contains information on the latest snapshot. Of course, we can have plenty of snapshot, but it records only the latest snapshot, which will be referred to the next commit. Okay, let's see the anatomy of Git project. As a parent directory, we have our working directory here, which is this, and within this working directory we have both a staging area and .git directory, and of course we can see a file, the folder named git literal, and within this git literal we have .git folder. And let's say we are creating a file or just any action within our working directory. It could be creating, editing, or deleting. And at this moment, Git do not track any change within the folder, and it has no recollection or record of those files. It just flag it as untracked files. Then we are staging as in snapshot. So as we've seen it in the diagram, we are simply creating a snapshot, which is the binary format referred by the SHA-1 algorithm to create the blob object. And this snapshot, which is referred by the SHA-1 algorithm, 40-digit hexadecimal value, will be committed by the commit action, and the snapshot blob file is saved in Git database permanently. And then last but not least, we have the comments. At first, we have this git add and file name, or we can refer to the entire project. When we say git add, we are taking a snapshot, which is of course creating the binary object referred by a 40-digit hexadecimal value. And then when we want to permanently save the snapshot, we will type git commit with -m and message value. Then after that, if we want to check out or recreate what was within our Git database, we can refer using git checkout, and checkout will build file or bunch of files from saved snapshot or the binary object referred by the commit action, and it will replace any file, of course, that was required by the checkout command, and files are being built from snapshot onto working directory. And yeah, this was the introduction, and I'll see you in the next part. Thank you.